Hello and welcome back to the Arduino Python series, and this is the tutorial number 12. So far we have blinked LEDs, read sensors, control servos, read buttons, read potentiometers and different other things. But today we are going to get things moving literally. We will be driving a gear motor using an L298N motor driver module and an external 12-volt power supply. And as always, we will control everything from Python using the Python2 library. By the end of this video, you will understand how to connect a high power motor to your Arduino safely, and how to write Python code to control its speed and direction. But before we look at the code, let's quickly see how we connect everything. The gear motor needs more current than the Arduino's 5-volt pin can provide. So we use external 12 volts supply. The L298N acts as a bridge. It takes the low voltage control signals from the Arduino and switches the high voltage motor circuit on and off. Okay guys, let's just start wiring our hardware and set up the hardware. Okay. So this is my L298N module, okay? And as you can see, there's two pairs of terminals, these sides. These are the output of the module. So these two, you can use each one of these two pair to just drive two motors. So if you have two motors, you can drive one from this pair and one from this pair. And these three pins, if you look at from here, the first pin, the first pin is the 12 volts. It's the input from your external power supply. This is my external power supply, so maybe yours is different, maybe you're using the battery ones, but I am using this one. It doesn't matter which one you're using, just you have to use an external power supply. So this is the input from your power supply. This is the GND, the middle one. So this is the GND, and it is a command GND, so one GND goes to your Arduino board. Or if you are using from your breadboard, it goes to your breadboard, doesn't matter where. And the third one, or the first one from the right side, if you look at from here, okay, this one, it's the input from your Arduino board, the 5 volts that come from your Arduino, or again, if you just jump from your Arduino to your breadboard, it comes from your breadboard. And these pins, okay, this section and this part is very, very important, guys. Please pay attention. If you can see here, okay, you can see there's a plastic jumper, okay? So there's two pins here. This plastic jumper, it just connect these two pins together. In order to use, the PWM pin in our program, you have to remove these plastic. See this one, okay? So this plastic, it was here, like this one here. So if you want to drive two motors and control the speed of two motors, you also have to remove this one too, okay? So see, there is two, but because I have only one motor now, so I remove the first one. So if you look at from here, this one is called ENA1. This pin is ENA1. This pin is IN1, IN2, IN3, and IN4. IN1 and IN2 to control the direction of the first motor, and the IN3 and IN4 is to control the direction of the second motor, and the ENA and ENA and ENB. It means enable A and enable B. These two goes to the PWM pin of your breadboard to control the speed of your motor, okay? So now let's start wiring. Okay, so as I told you, this is the middle one is the GND or the ground. Okay, so I'm gonna just connect the wire to here, and this, oh, let me just make it in the middle. Okay, okay, this is good now, see, and this is tight. Okay, and this one, the first one is the 5 volts from your Arduino board. Okay, so I'm gonna just connect it here. Okay, and as I told you, if you look at from here, the first pin, the first one is the input from your external power supply. Okay, so the red one, sorry, here, the red one. Okay, so the red one is coming from the plus. Okay, so I'm gonna connect it to here. Okay, okay, just make sure that your connection are tight. Okay, and these two, okay, see, out 1 and out 2, they goes to your motor. Okay, and doesn't matter which one you connect, it doesn't matter, so it's completely up to you. Just take a chance and connect it. Okay, I'm gonna connect it just like this. Okay, just guys, make sure that all your connections are tight, because it may just affect, you know, your hardware and the result. Okay, and okay, that's it. So I connected my motor, my DC motor, to these pins, you know, to out 1 and out 2, and here the first one, the input from the external power supply, and these two, so the middle one is the GND, and the first one goes to the 5 volts from your Arduino board. Now let's just start wiring the, okay, just like that. Okay, so as I told you, see the first pin here, the ENA or enable, it's for controlling the speed. So I'm gonna connect here, and I'm gonna use pin number 10 on my Arduino board. Just be careful, guys. You have to use a pin that, you know, have the PWM capabilities. So one of the pins on the Arduino board is pin number 10. So I'm gonna connect it to pin number 10. Okay, just always double check, because, you know, the pins are very small and near together. So be careful not to make mistake. And the IN1, as I told you, IN1 and IN2 here, you know, these two pins, they are for controlling the speed of, sorry, the direction of your motor. So they go to pin number 8. Okay, so pin number 8 and pin number 9 of your Arduino board. So I'm gonna connect the IN2, okay, to pin number 9, just like that. It's just okay, so this is it. So these three, you know, 8, 9, 10, you connected them. So the ENA1, or it's the ENA, sorry, the ENA or enable goes to pin number 10, PWM, and IN1 and IN2, okay, goes to pin number 8 and 9. Okay, that's it. Okay, So now, see, as you know, this is the 5-volt pin, and these two pins are G and D on your Arduino board. So I'm gonna connect the 5 volts. Okay, I'm gonna connect it to here, to my breadboard. Okay, so this is the plus and this is the minus of my bread. Doesn't matter, you know, I just, because there is the sign, so I'm using this, and the G and D, I'm gonna connect it to here. So all these, you know, lines, all these, you know, the vertical, it is now plus or 5 volts, and this one is minus or G and D. And as I told you, this is the GND. This is the GND from your module. So I'm gonna connect it to here. Doesn't matter which one, because all these, they are negative. And one more GND, okay, from your external power supply. See here, guys, from your external power supply. So you also have to connect this GND. How you can connect it? I can easily just wrap it like this. Okay, this is it. And I'm gonna connect it again to the negative, like here. And one more wire left, just the 5 volts of your motor driver module. Okay, so this is the whole wiring and the hardware setup of our system. But one more time, guys, please do not forget to remove this plastic, you know, jumper from your module. It's very important, otherwise you cannot control the speed and you always have a constant speed. Okay, so this is it. Let's go and start the coding. Okay, now let's open our friendly Visual Studio Code, and I think so you all of you already know that the first step is to create a new file. I'm gonna call it, for example, like gear motor, okay, dot py. Okay, this, just be very careful about this .py, guys. I'm just telling you all the time because it's very important. Okay, so the first step is, you know, importing the libraries. I'm gonna just I will say from Mata2 import Arduino, and as usual util, and also import time. Okay, so now let's set up the Arduino connection. How we can do that? I can say port. So I am just connecting through COM port number 9. But guys, pay attention. Yours is definitely different than mine. So go to your Arduino ID and check which port you are using. I explained it so many times before that, so I won't explain it anymore. Just if you don't know how to do that, go and watch the other videos, please. Now I'm going to say board equal to Arduino through which port? Through this port. Okay. So we define the serial port where our Arduino is connected. Okay. Now the next step, you know, starting our iterator. Now I'm going to say how we can start it. We can use it by this utility library. I'm going to say iterator equal to util. I'm going to use our utility library iterator, open and close parentheses. Where I want to use it, I want to use it on my Arduino board. So now I have to just start my iterator dot start, open and close parentheses, and I'm gonna just add a very tiny slip here. I'm gonna say 0.1. okay. So, you know, here, so, you know, Fermata is a protocol that runs in the background. The iterator continuously reads incoming data from the Arduino, and, you know, things like sensor values, all the things that we have in our program. Even though we are not reading sensors today, it's good practice to start it. We give it a short delay to just settle, Okay, now it's time to define our motor pin. So the first one is in 1. I'm gonna call it in 1 because it's in 1. If you just see on your module, it's in 1, so I'm gonna just exactly the same name, in 2. You know, when you see this one, I just write everything in capital. It means that they are constant, so they won't just get changed in the entire program. Okay, and okay, so this line, the third line that we want to write now is very important, guys. It's really important. So I'm gonna call it, I want to define the PWM pin. I'm gonna say motor PWM. I'm gonna say board. How I can define it? I'm gonna say board dot get pin, exactly like, you know, what we were doing with the LEDs and these things. So it's digital colon pin number 10 colon and PWM. So I'm gonna use P. So, you know, as I told you, the third line, this line here, is really important, guys. We use board.getPin, this one, to set up pin number 10 as a PWM output. The string D10P means digital pin number 10 used as PWM. And the P, you know, the P here, the P tells Fermata that we want to use pulse width modulation, so we can vary the motor speed. Okay, now so we finished just setting up the pins. Now we have to go to the next line. Okay, so now, you know, we want to just print the messages in the console only when for example, we just changed the direction of our joystick, the motor, you know, only just when the direction or the speed of motor change. So then after that, the messages show on the console. So not just all the time, that even if the motor stops. How we can do that? We just have to define two variables. I can say last direction. I'm going to call it last direction. I'm going to say none, because at the beginning, because so far there is nothing changed in the direction. And also I'm going to say last speed. Yeah, I'm going to give it -1. Okay, so these two variables help us avoid flooding the console with print statements. We will only print when the motor command actually changes. So last speed here, last speed is set to -1 initially. Why? Because the speed is always between 0 and 1. So, at the beginning we said -1. It means so motor is completely stopped. Now it's time to create the motor control function. Okay, so how we can do that? I'm gonna say def, and I'm gonna call the function as set motor. Okay, so I'm gonna give it 2 arguments because I want to control speed and direction. Okay, so I'm gonna give it speed and direction. Okay, now because I want to change, you know, these 2 variables, they are outside of this function, but I want to use these 2 variables inside this function. So I have to use something called global. Okay, so I'm going to say global last direction and last speed. Okay, so now here we define the function that does all the work. It takes 2 arguments. See, speed and direction. Speed is a float from 0 to 1, and direction is only 3 strings in our project, you know, backward, forward, and stop, you know. And we need to modify, as I told you, to modify the global variables, so we declare them in the global. Okay, so let's continue. As you can remember, I told you, you know, because these joysticks, these are, you know, mechanical buttons, mechanical things, they may just bounce, you know, they may just have some noises or other things. So maybe even if the joystick is at the normal or in the middle position, but very, very tiny movements gonna happen to our motor, okay? But we want to prevent that. We want to avoid that. How we can do that? I can say, you know, I want to just ignore very, very tiny changes, you know. I can say if direction equal last direction and absolute, okay, speed minus last speed, if one of these two smaller than 0.03, then what happened? Then return. Okay, so what does this mean? This is a little optimization. If the direction is the same as before and the speed change is less than 3%, we do nothing. It prevents unnecessary updates when you might be turning a potentiometer or your joystick very, very, very slow. But what if it's not true? I mean, what if the change is this change, one of these change is bigger than this? What we should do? We want to update the stored values. How we can do that? I can say last direction, okay, equal to the new direction or direction, and the last speed equal to the speed, okay? So with these two line, you know, it means otherwise if one of these two conditions are not true, we update the stored value, okay? Right. Now it's time to just define the direction, okay? All right, how we can do that? Now let's start with the forward direction. I can say, you know, for the forward direction, for example, you know, one of these pins, these two pins, they are for direction, and this pin, PWM, is for speed. You know, if, for example, we want to move forward, you should just turn this pin on or high, I mean 1, and turn this off. And if you want to do opposite, you should do vice versa, okay? Now, let me just write it down, and you will just come to know very perfectly. So I'm going to say if direction equal, I'm going to say forward. Okay, now we're going to use later, you will see that we need this forward. We're going to just define this forward. When we call this function, we're going to use this forward. Okay, so if direction equal forward, then what's going to happen? I'm going to say board dot digital. I want the first pin, I mean in 1, okay, in 1 dot right, okay, 1 or high. It means turn this pin on. So as I told you, when you turn one of these pins on, you have to turn the other one, the opposite pin, off. Okay, so how can we do that? We can just very easily copy and paste this, but instead of in 1, you have to change it to in 2 and write it to 0. Okay, so simple. Okay, so this is for the forward direction. Now we have two other directions. One is backward and the other one is stop. Okay, so they're going to be exactly the same, but because we have two more, we cannot just use else here. You have to use elif. Okay, elif. Now we're going to say direction equal. I'm going to say this time backward. So what's going to happen? Exactly, you can again copy and paste these two lines. Okay, but this time in 1 should be 0 and in 2 should be 1. Okay, that's so simple. And just one more. Now for this stop, we can do exactly the same thing. Now this time you can use else. So I mean, if none of these forward or backward is gonna just use, so we can copy these two lines and paste them here, but this time both of them should be 0. Okay, and also the speed, we will just make the speed also to 0 as well, right? So here we set the 2 digital pins according to the desired direction. For forward, we set in 1 high, in 2 low, and for backward, we set in 1 low here, in 1 low, and in 2 high. For stop, we set both to low, and we also force speed to 0 to be safe. It's not just necessary, you have to put it down, but it's just safety. I just put it here for safety, okay? Right. But so far, we just defined the direction, but there is one more element left. We have to just set the speed of our motor as well. How we can do that? It's so simple. Again, guys, I'm gonna say motor. I'm gonna call it motor motor PWM. Okay. So, but here we said, okay, yes, motor PWM. Sorry. No, not, we shouldn't use it here. Okay. We have to use it in. Oh, okay. No, it was inside the fine. Oh, yes, it was correct. Sorry, it was correct. Yeah, it was correct. So we're gonna say motor. Yeah, motor PW. Let me just see. Okay, yes, we have to use this pin. Here we can say motor PWM dot right, and we're gonna give it the argument of speed. Okay, so this is the heart of speed control. Motor PWM dot right speed, accepts a value between 0 and 1, which corresponds to the duty cycle of the PWM signal. So 0 means 0%, it means motor off. 1 means 100%, it means full speed. Any value in between gives, between these 0 and 1, give you the proportional speed, right? Okay, so now finally we're gonna just print command. We're gonna print something so we can see what's happening on the screen. Okay, let's say print. Let me just go online up. Okay, now I'm gonna say print. Don't forget to use f string because we want to use other variables. So I'm gonna say motor direction equal to which direction. I'm gonna pass it the direction argument, and I'm gonna use, for example, like the separator, and I'm gonna say motor speed equal to, with what speed? I'm gonna say speed. So I just wanted to show it in 2 digits of the decimal point. So I'm gonna say dot to f. Okay, so this is it, guys. This is with the function. So I think nothing's left in the function. So we created our function. That's it. Now it's time to just write our main loop. Okay, because we want to just, as I told you before, safety always comes first. So because we want the emergency button too, so we're gonna use try except block. So I'm gonna say try. Now I'm gonna say while true is true, so this program will just run forever. So I'm gonna say we're gonna call this we're gonna call our function. Okay, this function I'm gonna call set motor. So I'm gonna give it to see here. So it had 2 arguments. So I'm gonna give it the 2 arguments. I'm gonna say, for example, with 0.25, this is the speed, and I'm gonna give it the direction. I'm gonna say forward. Okay, for how long? I'm gonna say time that slip I'm gonna give it 2. Okay, so it will run forward at 25%. This is for the forward. Okay, now I can just copy and paste exactly the same thing for the backward and also for the stop. So I'm gonna say, but this time for the backward, I want, for example, like 75% of speed. So you can just see the difference. Now instead of forward, I'm gonna say backward. And one more time for stop. So I'm gonna set the speed to 0, 0. Okay. And instead of forward, we're gonna say stop, and again for 2. Okay. So here we put our main code inside a try block here. So we can catch a keyboard interrupt. Okay, that is when you press the Control C or the emergency button. So inside the infinite loop, we call set motor, or our function, this function, with different speeds and directions, and pause for 2 seconds. This 2 in seconds, so 2 seconds for each time. This gives you a clear demo. So the motor runs forward slowly, then backward faster, and then it will stop. Okay, so now it's time to define our except. So I'm gonna say except keyboard interrupt. So I want to say when you press the emergency button or where you press the Control C, just stop the motor. Okay, so I'm gonna set motor. Okay, I can just copy and paste this line exactly, but doesn't matter. I just type it down 0 and go to the, sorry, don't forget about this code, stop. Okay, and also just exit from the program safely. How we can do that? I'm going to say board dot exit, open and close parentheses, and at the end print a goodbye message. You know, for example, like program stopped safely. Okay, so when you press Ctrl C, the program jumps here. Okay, jumps here. We stop the motor, close the connection to the Arduino with board.exit, open and close parentheses, and print a friendly message for the user. Okay, guys, so I think everything's fine. And we finish coding. Now that you have seen the code, okay, now it's time to run our program and see what's gonna happen. Just before we run the program, I think, let me just explain to you a little bit more about, what is this PWM. You're already familiar with this, I know, but I'm just explaining a little bit more. PWM, or pulse width modulation, is a way to simulate an analog voltage using digital pulses by turning a pin on and off very fast and varying the percentage of time it's on. So it means the duty cycle. So we can control the average power delivered to the motor. In our code, for example, like, a motor PWM dot write point.25. Okay, let me show you what I mean. In our code, like I said, motor PWM, okay, dot write 0.25. So this line means the pin is high 25% of the time, so the motor gets about 25% of the full voltage and spins slowly. Okay, that's it. One more thing, guys, I want to tell you about the L298H bridge. The L298N is an H bridge driver. It contains 4 switches that can route current in either direction through the motor. By controlling IN1 and IN2, we tell the H bridge which way to send the current. The enable pin ENA acts like a master switch. If it's low, the motor is off regardless of IN1 or IN2. By connecting it to a PWM pin, we can chop the enable signal and thus control speed. Okay, And one more thing about the external power and common ground. Motors can draw hundreds of milliamps or even amps, far more than the Arduino's 5-volt regulator can handle. That's why we use a separate 12-volt supply for the motor. But the control signals from the Arduino need a reference. If the grounds are not connected, the voltages won't line up and nothing will work. So we must connect the ground of the 12-volt supply to the Arduino's ground. This creates a common reference point between, our power supply, and the Arduino. Okay, guys, now let's just run our program and see what's gonna happen. Okay, so I just pressed run. Just take a look at the wheel and let's see. Okay, yes, see guys, everything works perfectly. So forward 0.25, backward 0.75, stop 0.0. Again, forward 0.25, backward 0.75. Yes, and you can see, the speed that has changed, in the directions. Okay, everything works perfectly, guys. Now let's just test the Control C button or our emergency button. Let's see if it's gonna work. Okay, we will wait for the motor to start spinning. Yes, that's great, guys. So our program worked perfectly. And that's it, guys. Hope you liked it. See you in the next lesson.